Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.
Hey everybody, welcome to SkyTour Livestream. It's I, Mark D'Antonio, with you again for another night of Comet Tsuchinshan-ATLAS, along with Daryl Mason. Hello Daryl, how's it going?
Hello Mark, I'm well, thank you. How are you? Hello everybody.
Doing great. Yeah, so it's another great night out in the observatory in Arizona, and things are moving along out there. We have the comet right here. There it is, right in front of us. Comet Tsuchinshan, and I guess depending on your dialect, it could be pronounced Tsuchinshan. But we're looking at the tail of the comet here. It's moving about 150 to 160,000 miles an hour. It's just over half of an astronomical unit away. So we're talking about a huge amount of distance away here, like 46 million miles or so from us. And it's actually really neat because we see the coma of the comet. This is that round open area here. And then we see this tail. What you don't see up close is what's causing that. The nucleus of the comet is basically a small asteroid, and it's coated with billions of years of accumulation of ice, dust, and other organic compounds that the universe has aplenty and that our solar system started off with. And so we're seeing that here. We're seeing what happens when heat from our sun warms that ice, those ices up. And the ices are of all kinds. We've got let's see, we've got ammonia ice, methane ice. That's 2 Starlink satellites in one shot right there. Ammonia, methane ice, carbon dioxide ice, water ice. We have all kinds of ices on this comet. And we have organic compounds that aren't ices that are bound up in those ices. So those end up getting adhered to this asteroid nucleus. Now, how does that happen? Way far out. Way farther, much, much further out than Pluto. There is another belt called the Kuiper Belt. The Kuiper Belt is a disk of objects, and beyond that is another one called the Oort, O-O-R-T, Oort Belt. And then there's an Oort cloud, which surrounds the solar system and goes out literally just beyond halfway to Alpha Centauri. It's that large. And out there's very tenuous gravitational attraction to our sun, and a passing star over millions of years could perturb it just enough to send it on that long journey in toward us, the inner solar system, which is what's that?
Go ahead.
What were you going to say?
Well, dumb question time already. Wouldn't it stop being our Oort cloud once we were halfway to the next star?
I guess
it would be.
true.
It would be for the other star.
I would guess that's true, except that I've heard estimates saying the Oort cloud goes even further, and no one's addressed the gravitational issues. And I have a feeling it has to do with the fact that the Oort cloud is so large and expansive that the other side of the Oort cloud is way further away from the nearest star than the side nearest to it. So only the elements that are in the nearest side to that other solar system, the other star system, Alpha Centauri, would probably have a chance of being perturbed into it. And maybe there's been sharing, for all we know.
I would think. I mean, Alpha Centauri as a system has more mass than our sun does.
Yes.
It's like 2 comparable big stars.
Yep.
And then the little red dwarf. I mean, if there's more mass, a greater gravity well in that system, I'd think it would hand off, from Sun to Alpha Centauri in the middle or even beforehand.
I would think that's possibly true. It has to do with velocities and the motions of the objects in the Oort cloud. And I don't think anyone's done a study to look at shared objects between Alpha Centauri and the Sol system. Our sun has a name, by the way. It's Sol, not Sun. SOL is the name of our system.
I know that.
I'm talking to everybody listening, of course. All right, we're going to try and do an exposure here. Let's try 12 seconds to start with and see what we get. Now, this is a live view. It's changing every second. But now I'm going to a deep sky mode where we're going to use what we call stacking. We're going to take a second image, align it with the first, and stack it, and stack images on top of each other. Hi, Elise, how are you? And that's what you get. Now, wait, there's more. All we have to do is bring this down, get rid of this guy right here. All right, and now we're going to process this for color, and then for processing brightness. And now we get a very different look. This is the extent of the comet right here. You can see the nucleus here. We call it the coma. Okay, and then here's that tail, the dust tail, going all the way out. Conspicuously absent tonight, Daryl, apparently, I don't see it yet, is the antitail.
Yeah.
We're going to have to see if the antitail is still with us.
I've been expecting it to go away sooner or later. It can't last forever.
No.
Michael H's first question for tonight. Mark, how long at comet speeds would it take to get to Alpha Centauri?
Well, you're looking at 25 trillion miles to get there. All right. At 6 trillion miles per light year. All right. So it comes out to about 25 trillion miles divided by 150,000 miles per hour, and that'll give you the hours that it would take to get there. And then you can multiply that by the appropriate conversion factors of, you know, 24 hours per day times 365 days per year, and you will end up with your number of years that it would take to get to Alpha Centauri at comet speeds.
A long time.
Yeah, that's true. I'm going to increase the beauty of this right now. I'm going to click this button. Watch this. Boom. Yeah, see, now we're getting even cleaner look. That's pretty. I'm seeing maybe a subtle anti-tail here, Daryl.
Yes.
I'm going to come back to our segment here. This white curve is our average of the red, green, and blue curves that you can see there. I'm going to pull our black level just to the left so we can actually get a better view here. We still have sunset light out there, so I've been fighting that. That's what we're doing right now. But it's okay. It looks great.
I don't think I can put trillions in my calculator.
It's an extra set of zeros. Very nice. So the comet, okay, this is cool. I want to show you something. We're gonna look right, and I'll show you where I'm gonna look. Okay, first of all, for those that are just joining us who haven't been here before, okay, I wanted to share with you. Okay, this is the telescope control over here. This is the telescope computer. This is the telescope in the building, which is 2,600 miles away from me. This is, well, that's Big Mouth, that's me. This is our stacking screen. It shows us how many images have been stacked. You see that number right here. You see that number right here. Okay, this is our exposure. This tells us how long we're taking a picture for. And the gain tells us how sensitive we're setting the camera sensor to. So we balance off higher gain, which produces fuzzier images, with lower gain and longer time to get a nice average mix. And that's what we've done here. So that's what we see here. And now what I wanted to do was to show you something really interesting, and that is here. I'm going to surround the nucleus here. Okay, there's the nucleus. And right there, you see that little star? I want you to watch that star in the next set of exposures we do after we clear it. Okay, you see how the nucleus is right here and the star is right there? You're going to see this comet actually move. And I'm going to show you how. We're going to take this and save it, because we've taken 19 shots and 20 shots. That's good. So we'll save it. And what happens now when I hit save, it's going up to skytourlive.org on our server. And if you go up there in about 30 seconds, this very picture will be up there for you to take and download for free. Okay. However, we're going to do this. We're going to clear this now. See that little star? Look where it is. Okay. All right. So we're going to clear this now. All right. And go back to our 1 second. It's actually a what I call our low light view. Okay, and we'll do that. I'm going to get rid of this. That's our. Okay. Okay, we're going to get rid of this guy. It's our stack. Go back to our 1 second view here. Yeah. Okay. So remember that little star right there.
Can you zoom in a little, or did you already?
No, I didn't. I could.
Okay, now I see it.
There's the star we're looking at right there.
Yeah.
And we're going to watch how the comet's going to leave it behind a little bit.
You see, there's actually several stars in a row right across the
You're right.
front of the comet.
Right there. And there's one that looks like it's coming out right there. Now, you see the tail going to the left. It makes you think the comet's going to the right. It's not. The comet's tail is based, it's created by the solar wind. So the solar wind is pushing this stuff out from the comet. So a comet's tail will whip around and it'll go into its tail on the way out. And that's what's interesting now. There's two tails a comet has. One is called a gas tail or an ion tail, and that's from ionized material on the surface of the comet that goes straight back. Those are usually blue. And the dust tail is just the material on the surface that we talked about, the ice that's boiling away particles of dust and everything that gets into the area around the comet. And that dust tail is pushed away by the solar wind, but as it goes around the sun, it kind of fishtails. And as it fishtails around the sun, the end of the tail could be seen by the nucleus, and from our perspective, it can look like the tail is sticking out in front of the nucleus of the comet up here, but it's really a perspective effect if this is the nucleus. Okay, that's the tail. I'm doing a diagram you can't see because I'm doing it online there with the webcam. So there's another star here that's now peeking out. As you can see, it's fully out now. See that, Daryl? It was hidden inside the coma moments ago.
Yes.
And it's coming out. That's good. This star is now further away. Yeah. So you're literally watching the universe change right before your eyes. See that? That's kind of cool. Really cool. Okay, so I want to say hello to everybody that's here. I know that I saw a few new faces and a few people that have been here with us for a long, long time. Okay. First of all, Michael Hedrick was the first one here. Congratulations, you win. What do you win? I don't know. Okay. And then we have Al Santoriga. I know Al. Al's been a great guy, a good friend for a long time. And he and I are going to be speaking in Danbury, Connecticut at a conference on Thursday. Al, I believe you go on at 5. I think I go on at 6. Or maybe it's 5:30 and 6:30 or 5 and 6:30. I don't know. But the later part of the afternoon, the Danbury Library site will give all that information to you. Al has a very compelling talk. He's really a cool guy. Renee Cruz is with us. Hi, Renee. Nice to see you. Tiffany Echo. Tiffany is, of course, one of our super users and super friend to SkyTour Livestream along with Michael Tarr. And last night, or the night before, when we streamed, we actually did a giveaway. We tend to do giveaways thanks to Michael and Tiffany. They will provide us with equipment to give away. And we give away telescopes and binoculars. And we gave away a pair of binoculars the last stream. It was won by Creamers. And I would like very much for Creamers to be, connecting with us and get us to, what's going on here? I think there was a key that I hit.
Camera in still mode, it said.
Yeah, I know. I got you. Yeah, I don't know why I did that. Let me, Okay, so...
Are you on live view?
Yeah. Yeah, I am. Okay, so here you see, if we go up now, you'll see that star we talked about. Look, it's further away now. This star is even further out. You're literally watching the comet move through space. You literally are seeing the universe change before your very eyes.
Comet is basically moving the same direction the tail is pointing.
That's correct. Yeah, that's right. That's a good way to put it, too. I didn't say it that way. Yep. So that's really cool.
Well, maybe not directly. I mean, the comet has a trajectory. It's climbing up out of the plane of the solar system at a pretty steep angle.
Yes.
The tail is pointing straight away from the sun.
Yeah.
Which might not be the same thing.
Yep. What's going on here? The camera's in still mode. I don't want to be in still mode.
Start capture, quick capture, or a snapshot.
I'm just going to live view.
At least per your question, uh, early estimates were that the comet's orbit was 80,000 years long. Later estimates, some are saying now that it will never come back.
Really?
That it's, yeah. I don't know if that would make it a hyperbolic orbit or what, but it may be a lot longer time than 80,000 years and maybe
Yeah.
never again. When we have comets that come back regularly, when you see their scientific label, like Tsuchinshan here is C2023A3, when comets return on a regular basis, there's a P in there. Is it PC or periodic comet?
Yeah, P is for periodic.
Yeah. Instead of just a C.
There we go, it's Starlink again. Of course, this all comes to you courtesy of Starlink. I'm gonna do this right here.
Starlink had a launch tonight,
That's right.
but they canceled it, postponed it till tomorrow night.
Oh, did they?
Yeah, don't know why.
Okay. Okay. So you see those stars now are even further away. Let's do a image here. We'll do a 15-second image. We can probably get away with that now. It's probably dark enough to get away with it, so we'll do that. And we'll go into deep sky mode here. And we'll clear the previous image, which is under processed. Okay. Alright, so I finished saying hello to folks. I said hello to Tiffany. I said hello to... I didn't say hello to Daisy and Zoe. There you are. Eric, who is American Road Warrior, is with us. Hi, Eric. How are you doing? Nice to see you, brother. And now let's do color correction and then do a bit of processing. Okay, there we go. And then we'll just sit back and let this come in for a bit. Note that star we're talking about right here. It was right here, and now it's here. That means the comet's going this way. This star was in the coma and it has come out. Pretty cool. Nice. Alright, I'll just move this up a little bit. Okay, and I do see a little bit of an anti-tail. Look at it.
Mm-hmm.
It's faint, but it's there. It's at a steeper angle. Okay. And then let's see. We have Asher is with us. Hey, Asher. I said hi, Marco. And Lisa's with us. Lisa. And let's see who else is here tonight. Carl Becker, Sam S. Elise is here, like I said. Okay, good. Okay. And Jack the Lad. What's up, bro? If you guys are just new to the channel, please subscribe, because everything we offer, we don't charge for these images. They're going to be online for you at skytourlive.org. You follow the on our website, which is skytourlive.org, you follow the path that says take me to cool pictures, and you will get them. Cindy Murphy. Hi, Cindy. And if you're really interested, you can end up getting some of the stuff that we have taken pictures of. You can get it on a blanket or a mouse pad or a cup or a mug over here. Go to SkyTour Shop on Etsy. Up there in the corner. See it up there in the red? Yeah, right up here. SkyTour Shop has about 40 to 50 products up there that you can get. There's playing cards, coasters, the water bottles. It just goes on and on. Sneakers, clothing, you know. Really cool. And so those are all available for you.
Do you sell many mouse pads? I didn't think anybody used mouse pads anymore.
No, that's true. And we have them, but nobody seems to need them. Raul Robadilla is with us. How you doing, Raul? Old School's with us. Cindy Murphy got the really cool blanket. Oh my gosh. Yeah, really nice blanket.
I just want a coffee mug.
I know, you deserve a coffee mug.
You keep saying that.
I know. See, Marianne is not available right now. She's actually way up in North Country.
Oh, I'll pay for it like everybody else.
Well, obviously, as a co-host, you get something for nothing. All right. So
Okay.
Let's see. Yeah, so we'll get you. What do you want on it? What picture?
I don't know. I need to go look at it. At Etsy, I guess.
Okay. I'm also gonna. I want to make a Helix mug too. By the way, I don't have a Helix mug up there. I want to do a Helix mug.
You want to do a fun mug? Just put a saying on it, like astronomers love heavenly bodies.
Yeah, I guess I could do that.
Sell 1 million of them.
Well, is it my imagination or is this comet tail broadening?
Maybe a little, yes.
And the anti-tail looks like it's broadening.
Yes.
That's interesting.
Very much so.
Excuse me.
I have a coffee mug a well-meaning sister gave me a few years ago for Christmas.
Yeah.
It's got all the constellations on it. It's like black or really dark,
Okay.
with little stars and the constellation patterns, and it changes when you put something hot in the cup. The constellations stand out. It's okay. The constellations aren't in the right places though. They have Scorpius right next to Orion, which is on the opposite side of the sky, actually.
And violates the whole mythology story.
Yeah,
That's okay.
absolutely. But she meant well, and it's a Christmas present, so
That's cool.
I cherish it anyway.
That's cool. Yeah, so
I see a distinct line just about center of the tail.
right here.
Right, yes.
I see
Or
that
is there a
too.
dark line and a bright line?
Yeah,
I wonder
see.
if that's the gas tail we've been looking for.
Yeah, it's hidden inside. You notice this hint of green here? That's not an illusion. This hint of green has to do with the carbon atoms that are in the comet's nucleus and in the ices. And when it liberates those carbon atoms, sometimes those carbon atoms are bonded to a nitrogen atom, and that's cyanogen, which can make a very, very bright green ion when it's ionized. Also, other carbon compounds can ionize to make a green compound as well. And so this green compound, this green color, actually is the source of what was a major panic by Flammarion. He was, what, 1700s or 1800s?
Oh no, he was.
Oh, that's Haley. That was contemporary. He was contemporary.
Flammarion was the French Carl Sagan science popularizer back in the late 1800s into the early 1900s.
Yeah.
Well, go ahead.
Oh, no, that's okay. Oh, go ahead. You're good at telling that story too.
Well, he posited the chance that Earth might sweep through the tail of the comet and collect the poisonous cyanogen/cyanide gas detected in the comet. And that scared the heck out of a lot of people, and snake oil salesmen took advantage of it like they typically would. So they started selling comet pills and comet lotion and stuff that's good for what ails you when the comet comes by.
It did absolutely nothing, of course.
Yeah, and I always say it impressed Arthur Conan Doyle so much, the guy who wrote the Sherlock Holmes stories, that he wrote a short story about the Earth flying through the comet's tail and everybody on Earth getting poisoned and evidently dying, but then to wake up again a day or two later.
Yeah.
It's an oddball story.
It is, but it's also a true story about his book. Yeah, so the comet is basically, you might think that every time hey Isabella, you might think that every time the comet comes by, it's going to be losing some more of its mass as the sun bakes it off, and you're exactly right. So over and over and over, with these periodic comets that come back, this one may or may not be periodic, but the comets that go back and forth, like Halley's Comet that comes back every 76 years or so, okay, whenever we see a comet come back, they could be a little bit dimmer than the last time. And sometimes they will actually go and fall into the sun at one point or another. And sometimes the sun will actually consume them. That's only if they're on a collision course with the sun, which can happen.
That other comet that's on its way in, they think that's what happened to it. There was some hope that it would be another, Tsuchinshan-ATLAS. It's in the morning sky at present, and it's a Kreutz comet. It's a Kreutz sun-grazing comet. Kreutz is a family of comets that came from a parent comet a long time ago, a big one that shattered, and the Kreutzes all pass very close to the sun when they go into perihelion, and they think the sun basically, the tail was still there, but it looks like the nucleus has disappeared. That it flew too close to the sun, like Icarus did.
Interesting. And all that was left was a tail to keep moving
Right.
around.
Right.
Very cool. Okay, and so Isabella's with us. And, of course, Curtis Horn is here. Hi, Curtis. Nice to see you. The Goblin is with us. Goblin, a previous prize winner. A giveaway winner. I wish Creamers would show up again, because Creamer's supposed to write me a message because he won the binoculars, or she won. He or she, I'm not sure. And I have not heard from Creamers. This is nice. I'm going to save this now like this. Look at that.
You see.
That star is way out in front now, and this one is now this far out.
Yep.
We'll save it exactly as seen. Okay. Now we'll clear it and do it again. And why do I do that? Because if I do this, what it means is that we're going to end up getting a set of distinct comet images at a certain point. Then we could animate them, put them together, and make a GIF of the comet moving through the sky.
I was just going to say, I think it was Ronald suggested that the other night. If we got a good track on the comet across the screen over time, we could tell whether, which direction the nucleus is actually moving compared to the tail. Mm-hmm. Whether they are really still in the same plane or not.
That's right.
Thank you, Izabela.
This line is very sharp, and this line is not. That's probably a perspective effect, and that's a Starlink satellite. It's not a perspective effect.
They don't all have to be Starlink.
Well, the ones that we're doing a 15-second shot, and this is the brightness of the Starlinks, and they will fill the whole shot. They don't all have to be Starlink, that's true, but...
there's just so darn many of them anyway.
We usually see them.
Chances are it's a Starlink.
Yeah, that's true. Okay, Elise has a question here. Do you ever know when we're supposed to see another comet? Daryl was just saying there's another comet that's currently in the morning sky, but it looks like its nucleus has been consumed by the sun, and only the stuff that was previously expelled by the comet is left over. And so that stuff's still orbiting, and it's gonna come around possibly. I don't know when it's gonna come around. I don't know the statistics on that comet.
I want to say they were saying October 28th. I could be wrong, but hey, if the nucleus is gone, the the dust tail is just going to fly out into space and get thinner and thinner and disappear. 2 Starlinks
No.
following similar orbits, it looks like.
Yeah.
Elise, you never know when we're supposed to see another comet. Believe me, there are people out there watching every night, and dedicated amateurs and some professionals and automated search projects that are going out scanning the sky every night. And whenever somebody comes across a comet, they put it on a list, and people watch it and see if it's going to turn into a nice visible comet. Sometimes they do, a lot of times they don't.
Goblin asks a good question. So if a comet loses its nucleus, does it still continue through space? Yes, it does. And here's why. Because every particle you see in this picture, every single particle has its own orbit around the sun. Just because it was attached to a comet, at this point, the solar wind is pushing it back, but it's also in a particular orbit, also getting pushed along by the solar wind. So they're in an orbit. Now, yes, they will disperse over time, but the comet nucleus wasn't containing them in a particular region in space. They were free to go every which way, but the solar wind determines the direction they're going to go. So once the stuff is liberated from the comet, it's effectively not being held by anything other than the sun's gravity, like the comet is. So because the little tiny asteroid in the center of that comet has such a low gravitational value that it's not going to be able to hold this stuff down. As you can tell, it hasn't. Sorry, I think you were saying something, Daryl.
I don't remember.
Okay.
But Karen just made the point I was about to say, that this is the kind of stuff that forms trails out in the solar system, and the Earth, if the Earth flies through them, this is how we get meteor showers.
That's right.
Debris from comets.
Karen Belmont, you get a gold star. That's right. Comets are fascinating interlopers in the night sky. And you know what? Because we don't have a moon right now, we will also take a look at other things. But let's take a look at our all-sky camera while we're doing this, so you can see what we've got going. Here's the Milky Way. Okay. And you can see there's the comet right there. See that? There's the comet. And so the comet is actually rather prominent in our
I see it.
image here. Yeah, right here. See it? In that box.
Yeah.
Yeah. We have our
Looks more
summer
like-
Milky Way. We'll check out a couple objects in the summer Milky Way too while we can. That's a satellite up there that's moving through. Each exposure here is 15 seconds. Okay.
Izabela, I'm sorry.
Oh, go ahead.
Carry on.
No, what about Izabela?
We're just interrupting the heck out of each other tonight.
That's okay.
Izabela took note of that dark line and possibly the bright line right next to it in the image of the comet.
Okay.
And she mentioned it, and she has seen a distinctly dark line, and then there's a faint bright line right under it.
Okay, I see this. This dark line, I think, is an illusion because this is so bright. But you're talking about these lines here.
Yes, there's a faint dark line and a faint light line right next to each other.
Yeah. Now, if you remember Comet Churyumov-Gerasimenko that the Rosetta mission actually landed on, it had jets, and it was sort of a lima bean shaped thing. I actually have a physical model of it here somewhere. And it had jets shooting out, and of course it was rotating slowly. And those jets determine the nature of how this dust tail is going to look, in part because, like this bright line you see here, could be the result of one particular jet in the comet as it's rotating. forming that, and that dark space could have been a gap between jets. And there's more jets over here, more jets over here, a thick jet here, very few jets near the center of the comet as it's coming out, as it's rotating. So that's a very strong possibility. So the morphology of the nucleus can be kind of, but not very well inferred from the nature of the detail within the tail. And it definitely has an anti-tail still. Should have been gone a long time ago.
It is a bit more discreet now. I think still broad and faint, but
Yeah.
Izabela, I thought maybe the bright line we're seeing next to the dark line might be the gas tail.
Yeah, you were saying that. It might be. I don't see any blue. Actually, you know what? Let's try and do something here.
Yeah, well, as you mentioned, you saw some green in the head of the comet.
Yeah, I'm gonna try something here. I was looking, right, doing this, I'm looking for any bright line in our blue that might indicate a slightly stronger bright blue in here. Yeah, it's not showing it. It's probably pretty well subdued. Don't see it. Wow. All right, this is a number of them. Let's get rid of those. Now let's see. Our comet is still. If you look at the telescope, the image right above here. Here's the telescope, and here is the left wall of the building. And the telescope's bottom edge is a little above that left wall. You know, hello, Christine. How are you? Nice to see you.
Asher asked a question. Asher, the comet was closest to Earth on October the 12th. It was 0.47 astronomical units, or about 44 million miles away when it was closest. I've heard varying numbers since, anywhere from somebody said 50 million, 50s million, to 77 million last week. So it is moving away pretty quickly, but it was 44 million miles away from Earth at its closest.
Yeah. Okay. Elise asked a question. Hey, Robert Miller. She says, how do the comets get their color? The color that comets get is basically, the tail is basically the color of sunlight, because they're reflecting back sunlight. The comet halo here in the nucleus, that color is green, and that's because of carbon compounds in the nucleus that, when ionized and their electrons are kicked off the atoms, when the electrons come back in, they give off light. They absorb energy to leave, and they give off energy when they come back in. And that energy they give off, because of the nature of the atom itself, the carbon atoms, they predominantly come back as green color. They give off light, and that color is green. So it's basically through the chemical processes going on the comet that generate those colors. Ionization generates the green, and sunlight generates this yellowish white.
The process is much like fluorescent lights. You put energy through a gas, and it shines in a characteristic color.
Yeah.
Different elements make different colors.
That's right.
Neon is red, hydrogen is red, oxygen is blue-green, on and on. Carbon compounds tend to be green.
That's right.
Diatomic carbon makes a pure green color, and other carbon compounds will make more blue-green colors.
Yeah. As we said before, cyanogen, which is carbon and nitrogen, that will make a green hue as well. which led to, as we said, the Flammarion fear from the last apparition, that previous apparition, Halley's Comet we talked about. Yeah, so this is cool. All right, we'll save it and save exactly as seen, and then we'll get out of it for a bit.
That dark line in the tail just jumps out at me.
It does, doesn't it?
I'd almost wonder if, I mean, that's not the shadow of the gas tail, if that is the gas tail next to it.
No, I don't think so.
So,
I mean, there it is. It's pretty obvious.
yeah. Would that be the shadow of the nucleus? I mean, the tail is
theoretically possible, like contrail shadows. You know, I mean, we see.
Yeah.
Well, theoretically, I'm going to go to 1 second here, or low light mode.
That's really interesting.
It is.
I mean, I've seen dark lines in comets before. Sometimes anti-tails will make a dark line instead of a bright line.
Yeah.
Unless we're seeing anti-tail coming straight out toward us. I don't think that would be so in this case.
Yeah.
There's definitely a dark line there.
Yeah. Well, while we're here, I mean, the Comet, this is our attached planetarium that we use that allows us to also drive the telescope. We've got 3 different ways to drive the telescope. This is one, this program's another, and then this guy here is another. So we have some redundancy. But I wanted to show just one more thing while we're kind of in the neighborhood. Let's go here and check out this object. We'll come back to the Comet in just a few minutes. The Comet is still going to be high enough, but you'll notice the telescope is now moving. All right, we're going to head to the other object that's really cool in the night sky right now, and that's this guy. Now, this is a nebula called the Eagle Nebula. It's another Starlink satellite. It's the exact length and the speed that I expect. Okay, so the Eagle Nebula is the nebula that people know associated with the Hubble photo called the Pillars of Creation, because that's where you find them, is in this Eagle Nebula. And so once we're up here, and if we can annotate everything we do as well, so we can just say annotate this for me and we'll get the name, the Eagle Nebula. Okay, all right, and so we actually can do all that, and we can tell, hey, center it into view as well, and it will center it into view for us, which won't move it very far.
Mark?
Yep.
Isabella said your audio is low. You
My
sound
audio?
okay. You sound okay over Skype, yeah.
Okay, well, I'm not sure why. Let me see if I can make an adjustment here, Isabella. Tell me if this is going to change things. We're going to find out. How about this here? Oh, that's about as high as I can go. All right. Maybe I was just talking softer, or maybe a little bit away from the microphone. Thank you, Isabella. Okay, so there we go. So now what I'll do is we'll actually take a picture of this, and I will do a 25-second shot of this, and we're going to go out of low light mode and go into deep sky mode, because for you first timers who haven't been here before, you're going to just have a great time with this image coming up. So there's our previous Comet. We saved it. It's going to be up on our server at skytourlive.org, so not to worry there. So we can clear this image without loss of the image. It's actually saved perfectly fine. And now we're going to find the Pillars of Creation coming up next, and look at that. So we're going to color correct first. Okay, so we did a color correction. Now we'll do a little bit of a process on this to kind of process them, and we'll zoom in as well. So we're going to darken up the space behind. Now, do you know where the pillars are? They're right here. And I'll show you.
There's the Eagle.
That's right.
Uh, Eagle Nebula is today's APOD, by the way.
Oh, that's cool. I didn't know that.
Either the Hubble image or the Webb image, or possibly both
Maybe
combined.
the James Webb is probably really cool. I've seen that one. So the pillars of creation are these right here. These stalks, as we call them in astronomy. Okay, they're created by hot stars that are in the nebula and dense knots of dust and material at the ends of the stalks. What happens is the stellar winds erode all the lighter stuff around the outside of the lower density stuff and leave the higher density stuff alone because it can't penetrate that. So that means that in the background behind these stalks facing the stars, those areas are protected from these stellar winds. So we end up getting over time a long stalk left behind. And in here are fierce stellar winds in the between and over here. Okay, but in the middle, all right, I'll just zoom in temporarily into this for now. In the middle, this stuff, this dense stuff, is protected. So deep inside here, it's possible that we could actually end up finding planetary systems forming. See? So that's all very, very possible. All right, so I'm gonna kind of get rid of some of the noise here.
They're almost like shadows too.
I know, you're right. So there you go. There is this Eagle Nebula. We've got 2 here, and I think I got to get my filter, full width half maximum filter, adjusted. Okay.
Are we done with the Comet for tonight?
I don't think so. I think we're gonna do this one and go back to it.
Oh, okay.
Maybe one more time. Yeah.
You know, you should stop at M5 along the way when you go back to the Comet.
Oh, globular cluster.
It's, is it an Ophiuchus?
I thought so.
I think so. Unless I'm thinking of another one.
So there is this beautiful nebula. Look at that. And I will enhance it a little bit by turning on an enhancement. You see how it kind of looks a little soft on the edges here? Watch this now. I click this, and now look at that. We sharpen it up. And if we move a little up here, you see another object up here. This is right here. That's is it the fairy?
Yes. I was going to ask you to look at that. That'll build up a lot better if you continue with the exposures.
Yeah.
Yeah, it always looks like a hood ornament or an Oscar award to me, but it's lying on its side.
Right here, yeah.
Like at the morning after party or something, and somebody knocked it over.
Yeah. Well, let's try to add a little more clarity in here. Yeah.
I was close. Messier 5 is in Serpens,
Okay.
which runs right across Ophiuchus.
Mhm.
It's a very nice globular.
All right. Okay, this will be Eagle Nebula. And we'll save it. Why not? And we'll save it again. Okay, so just so you know, when I click on this image you see right here, this is saved up to our server, and you can download it. It'll be up there in probably about 30 seconds. So you can go to skytourlive.org, scroll down, and go through the instructions where it says take me to cool pictures, and you'll be able to get to it. Now, once we get our application live, you'll be able to go through several years of data. You can get every single Eagle Nebula we did all in one shot. So the application has a lot of features. And gee, who wrote that application? I think is something Izabela. Yes, Izabela, of course, superstar for SkyTour Livestream superstar. She wrote it, and she does an awful lot for us. So it's a beautiful app, and hopefully we will get that live as soon as possible. You'll notice that now we have 8 images stacked. You'll notice here that the clarity is getting better and better. That's because we're building this image stack I told you about. And as we build the image stack, all the noise that we see in between the stars goes away. We lose a lot of that noise, and that's really important. We get to see little features like this right here. That's called a Bach globule. It's a tiny globule that's a self-collapsing, self-gravitationally collapsing dust blob. Now it's going to be, a light year across or more, even more. And what that little blob is going to potentially be is an area where a star may form in the center of it, because what's also collapsing in there is hydrogen gas, the fuel for stars. And its own gravity will cause it to collapse into the center, but then it's going to make an accretion disk around it, a disk of material, because that's a natural fallout from gravitational collapse. And some of it's going to clump, and that clumping could lead to planets if there's enough dust. That's what happened here. If you want to look that up, it's called the nebular hypothesis. Nebular. I gotta drop the music a little bit. There we go. Okay, now I don't have a fight with the music. Okay, so then, go ahead, Daryl. Sorry.
Go ahead.
No, I'm done.
Whenever we see pillars or stalks like this, we see them all over the sky. Whenever we look at emission nebulas with like bright stars embedded in gas and dust, we always see dark pillars like this. The Rosette Nebula is a famous example.
Coming up too.
Uh-huh. Gonna be that time of year.
Yeah.
And there have been other ones we've looked at. I forget their numbers offhand, but up in Cepheus, north of Cygnus and Cassiopeia, some dusty areas of the sky, and lots of star-making stuff, so lots of pillars.
Yep. That dust is the magic which makes the universe happen, actually. You're here because of that dust. And I've always said, and it's a rather romantic notion, but in this dark area here, in these dark black dust areas, life began in the dark. And that's true. Life began in the dark. And so that's where the stars were born. That's where planets were formed. And so that's what we see. So in here, right here, at this point, okay, this area here is highly irradiated. Heavy-duty ultraviolet radiation beaming out. Stellar winds pushing back dust and gas, but leaving, not eroding denser areas away like this. And I saw a question earlier, and I think it was from Robert Miller. He asked, what is the dark spot at 5 o'clock in the nebula? Are you talking about this one? Or are you talking about that guy?
It looks like the little one you just pointed at.
Okay, that's the one I was just describing as the self-collapsing potential Bach globule. When I was getting my degree in astronomy, I had the fortune to be taught by Bart J. Bach for some classes, and Bach was the guy who found the Bach globule, and that was really something else, because the findings were very, very exciting and interesting, because it showed that stars and planets could form within these Bach globules, and that's kind of what we see now. Yeah.
Could we zoom in on the ferry for a minute?
Yeah. Hey, Tonerlo, how's it going?
Well, you stopped stacking at 11 images.
That's only because of this right here.
12. Oh.
Yeah, we're getting a little wind.
Still.
Yeah, and we got to refocus too. Yeah, we got to refocus. router focus here. That's probably another reason it's not stacking.
When you see that, can't make it out terribly well, but that's like her feet or the base of the Oscar over there on the left. And it's a slender figure standing up. Apparently has wings. Maybe that's why they call it a fairy. It always either looks like a hood ornament to me or a knocked over Oscar or Emmy or whatever it is.
Yeah. I'm going to go back and...
It's Pillar 2.
Yeah, that's right. I'm going to go back and clear this. I'll save it, then I'll clear it. But the thing I have to do now is I'm going to come back and I'm going to go back to low light mode and do a focus run because the focus has changed. So to get the focus fixed, we're going to come down here. You get to see that process. And I'm going to take these and move them out of focus.
Can I answer Carl while you're focusing?
Of course.
Carl says, if there was an Oort cloud, wouldn't it reduce our visibility capacity? Carl, if you watch science fiction movies, Star Wars and stuff, Star Trek, when they fly through an asteroid field, well, it looks like a field full of boulders out there. And I think the same thing would carry over to the Oort cloud, only more so, for what I'm about to say. In reality, if you were in the asteroid belt or in the Oort cloud, you would never see another asteroid or comet. They are so thinly spread. Now, asteroids, and I suppose comets too, do occasionally interfere with the field of view of certain stars. They usually have a good handle on when they're about to happen. They'll even issue alerts to go watch a certain star get occluded by an asteroid or planets sometimes. Planets will cross stars and temporarily block them. But just the distribution, space is so vast that, as I said, I mean, you could be standing on a comet in the Oort cloud and you wouldn't see another comet out there in space.
Just to drive home that perspective a little further, when we talk about, let's say, the asteroid belt, as Daryl's talked about the Oort cloud, well, let's talk about the asteroid belt as well. The asteroid belt is also an area where we got our focus. The asteroid belt is one where we'd also see that the asteroids are so far apart you wouldn't see another asteroid, all right, because they're so far apart. And if you add up, you ready for this? You add up the mass of all the asteroids we know, even the biggest ones, Ceres, and this next one, Vesta, okay? Even if you add those up, all their mass would still only amount to the mass that's about 1/4 of the moon. So we're talking about a very, very small amount of mass.
People get the wrong idea of watching Star Wars and Star Trek.
Yes, Star Wars.
You know, if they showed, they said they were flying through an asteroid field and you didn't see anything, well, you know, that's not very exciting.
Yeah.
So they feel the need to fill that darn place up with big chunks of rock and ice.
Mm-hmm.
In reality, it's not like that.
There's our comet. Should we go do one more comet shot before it sinks below the horizon?
Sure.
Okay, let's do that. All right, so we'll come back now that we're focused. Let's go back over to Comet Tsuchinshan and go there. You'll watch the telescope lift up and head westward. And we'll just back out of here a little bit.
Darn it, I can't type.
Can't miss that tail. Look at that. That's really pretty. Okay. Let's move a little bit more west. Move a little bit south. Hello, Hein Cherry. Didn't see you before, sorry. Incredible skies, what's going on? How do you mention here? I don't get it. All right, here we go. Let's right through it with a Starlink. Okay. Hey, Jungle, what's going on? Random, how you doing? Thanks for joining us. Okay, let's do a 20-second shot on the Comet now. And we'll come out of our low light mode and go into our deep sky mode. And you'll see the black screen from the cleared image from before. So now, this is our progress bar down there on the far right. We 1 second away, 0, and do we get an image? Yeah, we do. Look at that. Remember the 3 stars? Remember those stars? These are the ones. Look how much further the comet is. When we started, this star was right, the comet was right here. It's gone this far in the time that we've been watching it. And if you notice, we see this little dark lane through this. It's not as visible now, but it will be as we get more data coming in. Let's color correct. There we go.
I would say the comet appears to be moving pretty much the same direction that the tail is pointing toward.
It appears to be. It appears to be. There we go.
Moving to the upper left about 10 o'clock or so.
Yeah, just remember, folks, okay, the solar wind is pushing the tail, all right, and pushing that out. So as the comet goes around the sun, the tail swings around with it. So now the comet's actually heading into its tail effectively on the way out. That's how comets work, because it's all based on the solar wind. I just want to take a moment to say that I hope you guys are enjoying this. For those of you that are new, please subscribe, okay? Click the like, and give us a thumbs up. And we just want to help the algorithm, as they always say. But I think it's pretty cool. It's really neat to be able to bring you this stuff, because you're watching this live. This is absolutely live in the universe, right? And that's what SkyTour Livestream does. We bring you live stuff that nobody else does, you know. Oh, there's people that are running their telescopes and showing you what they're shooting that day or that night. But our telescope's a little bit special. This one is, you see it right here, it's actually running 25 times faster than the stock version of this telescope, because we have taken a telescope that has a photographic speed of f10, which is pretty slow, and we got it down to f1.8. So our telescope is very, very fast, and allows us to photograph things that would normally take minutes to an hour in a few seconds, or a few tens of seconds. And right now we're doing a 20-second shot of this comet, and look at the beautiful view. And luckily we're catching all the color and everything. It's just beautiful. So subscribe if you haven't. It's all free. And when I hit save on this image, by the way, and I'm going to come back to this here. All right. When I hit save on this image, what's going to happen is that the image will, in fact, go to our server, and the server is going to make the image available to you in about 30 seconds from the time I hit save.
Michael has a question of you.
Okay. Let's Let's just find out what his question is. How is it so bright? Do we know how wide the nucleus is? Loving this stream. Thanks, Michael. No, we don't. The brightness is due to the sun's light. Okay, the comet's not making light of its own; it's reflecting sunlight. And with a large diffuse object like this, with a large diffuse tail, it tends to look bright. Okay, but remember, we're also doing a 20-second time exposure. Okay, 20-second time exposure. Your eye doesn't really do time exposures. Your eye does a fraction of a millisecond, or several milliseconds, actually, for your eye. It doesn't do the same thing that a camera does. We just let the light keep falling on the sensor, and it builds up the image. Our eye can't do that. So the brightness is somewhat artificial, in a way. Okay, the actual. Go ahead.
I've heard the eye can
I do remember
integrate
say that,
integrate about a quarter of a second exposure.
Yeah, I knew you were gonna mention that because you have before. It's and that's possible, but a quarter of a second with a tiny
diameter doesn't
amount to much when it comes to astronomy.
Well, not compared to a 10-inch telescope.
Oh.
Michael, the comet is not intrinsically bright. Mark is building up the image on a camera, basically. The comet was naked eye bright last week, and it has since faded to 4.4, I think is the last I heard, which is as bright as a rather dim star. And one thing about comets, when they measure magnitude of comets, they're not looking just at the nucleus. They're talking about all the light in the nucleus and in the tail. So it's, even for a 4.4 magnitude object, well, that light is spread out over a large area, so the nucleus isn't really very bright either anymore.
Yeah, they have different terms for that. I mean, the combined brightness is kind of what they're talking about.
Well, it's a general thing. That's how they measure comets, so I know that.
Yeah.
Last week, I could see the nucleus naked eye. I could see the whole comet naked eye last week. Not as good as this, but I looked last night. I couldn't see the comet at all naked eye. I did manage to catch it in binoculars, and some of it may have been atmospheric conditions that night. It was last night. It was windy and turbulent air. But Mark's talked about averted vision before. If I averted my vision and binoculars didn't stare directly at the nucleus, it popped into view occasionally. Then it would fade out and then it would come back as the seeing fluctuated. Now, really great comets, I mean, they can be crazy bright. When you see Venus, like up in the west-southwest after sunset now, Venus is at magnitude -4. And minus magnitude objects are brighter than positive magnitude. Venus is the third brightest object in the sky after the moon and the sun, after the sun and the moon. Some comets, really great comets, can be brighter than Venus, but that's the total brightness of the entire comet. This comet was, when this comet was very near perihelion, would it be perihelion, or when it was closest to us? When the comet was between us and the sun, more or less, the comet was -4.9 magnitude at one time, brighter than Venus, but it was lost in the sunlight and we couldn't see it. And it has dimmed tremendously since then. It's dimmed tremendously in just the last week.
Yeah, and the tail of the comet will gradually diminish over time. We'll see at some point, not too distant future, I don't know whether it be another month or so, all we'll see is the nucleus left over, and we'll see it kind of like this. We'll see a little fuzzy blob. It might look like a galaxy, except it'll be moving. Okay? So this is something to come. This is what we're going to see. All right, so we are impacting the wall right now. So we're using the equivalent of about a 5-inch telescope right now, because this half of the telescope you see up above here, this half of the telescope and below is looking at the wall, just right there. So we've got about a 5-inch telescope, but that's okay. It still gives us plenty. I think moonrise is somewhere near 3 a.m., right?
No, it was a night from third quarter last. I think third quarter is like 2 a.m. on the morning of the 24th. So it still should be up well before midnight. Give me just a second and I'll find out. Moonrise in Wickenburg tonight is at 10:18 p.m.
10:18.
Arizona time.
Okay. I got my phase of the moon off. Let me look. I think my all sky was correct. 62.8. 62.6. Okay.
And I found this earlier.
Right there.
Yeah, October 24th at
Wow, that's pretty.
2:03 a.m. my time.
Okay.
Third quarter.
Oh. Okay. I'm looking at my clock. I'm in Connecticut. So I was 3 hours behind. I'm 3 hours ahead, basically. So I was doing the calculations based on that. How stupid. I forget the telescope is 2,500 miles away, because it looks like it's right here in my front yard.
Yeah.
That's really pretty, guys. That's really pretty. You can see some detail in that tail, too.
Yeah.
Really nice.
I still just barely see that dark line.
Yeah. I wonder if I
Yeah.
can...
I think the angle between the anti-tail and the tail is increased again too.
Yeah, right here.
Kind of pointing down more
Like this.
than the gas tail is pointing up.
Yeah, if we... I think we're looking, like, if you look at the nucleus, we're looking at something along this line right now.
Yeah.
And we got the tail going something like this right now. Yep. Okay. So. Yes, I don't want to be there.
They've been getting some cool images of the nucleus close up. There's a lot going on in there, like shell upon shell of gas and
Yeah.
motion of the head, like the spinning and stuff.
Yeah.
Pretty complicated.
I mentioned this to everybody before, I believe. That is that we're moving our telescopes to a Benson professional site, because the price is right. They're practically giving it to us, and we're going to have all our telescopes in one building. And one of the telescopes is a high focal length, high magnification system, and one of them is going to be this one, which is a wide field telescope. Now that move is not going to occur of this telescope right away. The other telescope will be at that Benson site very soon. This one is going to remain out here in the desert for a while now. I'm not sure how long, but we're eventually going to move them under one roof. But that next telescope will be able to see the nucleus a little different, And maybe with some filters, we'll be able to image a little more detail in the nuclei of comets. That's always sought after, so that'd be kind of cool. Wow, that's pretty dramatic looking right there.
Yeah. Now, where those 4 stars are,
Yeah, right here.
you can keep connecting. It's like there's a big sweeping curve of stars there. From there, all the way down in front of the comet, and then down beneath the comet. Pure
Yep.
coincidence.
Yeah,
Me and my lines of stars.
That's okay. Okay, let's save this exactly as seen.
Well, you know, if you want to take exposures through the f1.8 or f2 instrument and the f10 instrument at the same time, or even f7, those f7 images are going to be a lot longer
Exposures.
exposures.
Yeah, I know. Well aware of that. And that's why we're going to be focusing on different types of objects. We're going to be able to look at planets much closer and with more detail. So we're going to have a fairly rounded out system. Also, we're actually doing another thing out here on the East Coast. We're going to be creating a solar observatory out here. And that's in the works. I've been talking to folks about it already. And we're going to have, on every sunny day, we're going to be live streaming the sun and showing you the sun in the light of hydrogen alpha, so you can see the prominences and flares coming off the sun. So when they talk about a coronal mass ejection, you will have seen it with us before it gets here. That's kind of cool. Yeah.
Sometimes solar flares are so bright they show up in white light filters.
That's true.
Sometimes.
White light flares are rare, but they do occur. Yeah. Flares show up in a very high energy realm, because that's what they are, typically. All right. Thomas626, how are you? Can I see this thing in Southern California? It's very clear tonight. Where do I look? Well, I will show you right here, Thomas. I'm going to show you right now. Okay. Here is the comet in the sky. Now, right now, tonight, it's in the same spot as it is for you, a little bit higher for you because you're a little bit over in California. But right now, if you look at all the details here, let me show you the lines that you need to care about. The comet right now is about 20 degrees, 19 degrees, let's see what it says up here. 18.5 degrees above the horizon. Earlier in the night, it was way up here, and of course, it's setting. Okay. This will be available to you in if you have a night vision system like a Psionics Aurora, the Aurora Sport or the Aurora Pro Psionics. Then you could look at this very, very easily and see it very, very easily. If you have any kind of night vision system, you could look at it and see it. If you have regular binoculars, you need a really dark sky sight to see the comet right now. It was much brighter earlier in the earlier weeks, but now it's actually quite much dimmer. This kind of makes it look like it's brighter, but it's actually courtesy of our really fabulous telescope that it's looking so bright. We can actually see a lot of subtle detail down here, which is the tail wrapping around and being seen. So that said, I would say that you can see it. You just have to make sure the sun has fully set, because it will be in the sky. And in our all sky, you can kind of get an idea how big it is. There it is right there, Thomas. See that? That's the size in the sky. So that's kind of what you're looking at. And now you say, well, how big is that? Well, okay, this is the summer Milky Way. Obviously, it's huge. And this is the whole sky, right? So this is about, 8 degrees, 9 degrees of sky. It's a long tail. Yeah. Well,
Thomas, if you're in a
binocs are
reasonably
okay.
dark site, you can see it in binoculars.
Yeah.
If you're buried in Southern California light pollution, you may not see anything in binoculars. The comet is dim so much it's not visible naked eye anymore.
That's beautiful. That's a great shot.
I see a touch of red in the sky above the comet.
Yeah, I don't know what that is. I made it color correct. Okay. Izabela, thank you for putting up the link to our server. Thank you. You can always get there, guys, by going to skytourlive.org and scrolling down and saying, take me to cool pictures. You can also join our Patreon. We'd love to have you. As members of our Patreon, there's a whole bunch of stuff that you get. The higher tiers actually get finished processed images that are highly processed. And we're also offering, we're going to offer swag too, like those mugs that Daryl was talking about earlier and things like that. So for the higher tiers, you're going to get things like that as well. We're just working on the final details now, but you'll be getting mugs and things. Thank you, Izabela, for all the links there. Yeah, as Daryl says, we're if you look at our all-sky camera, I'll show you one more time. Now, this looks bright, but it's not bright. Believe me, this is actually pitch black. Okay, it's a very sensitive camera. This light you see here, this is Phoenix, 80 miles away. Okay, downtown Phoenix is directly 80 miles away from the observatory, and so you see here there's a cloud in the distance. You'll notice it looks dark. The clouds, when they're overhead, look black against the sky. That's because they're so bright. Like we got a satellite moving right there. This is a 15-second exposure, so in 15 seconds it's gone that far. It's fun to look in the different frames. You see satellites and meteors all night long. You know, satellites can be seen even after midnight if they're high enough in altitude, but they're very, very faint. So, okay, so
I like the black Pleiades mug.
Oh, you want one of those?
Sure.
Okay. All right. Let me make a note of that because I gotta get you one of those. That image looks really good. Okay, black Pleiades mug.
Izabela posted the Etsy link, so I went over for a look.
Oh, good. All right, I'm going to. And the Pleiades mug looks really pretty. All right. All right. I sent it in. Okay, good.
Ray, I wonder if Dark Sky International changed their name from International Dark Sky Association, or if it's a separate group. I used to belong to the IDA. I wrote about light pollution 30 years ago, and we thought we saw some minor improvements for a while, but it's completely out of control. And I've come to think that fighting light pollution is a fool's errand anymore. I hate to say that, but it's just a fact of life. I mean, the light pollution here has gotten so much worse. I used to be able to see the Milky Way from my yard, and not anymore. The town I live in is 500,000 people now, and the lighting is just completely out of control. They have light pollution controls on the books, and they ignore them. The city and the county both. The entire state, basically.
That's because no one's taking them to task.
Yeah, well, I got tired of banging my head against the wall.
Okay. You'll notice this star right here, that little tiny star right there, guys. Okay, that little guy, that guy right there, that little star, this guy right here. We're going to watch that star because that star is going to be a little further away from the comet nucleus as the comet nucleus heads this way. And in subsequent photographs, that's going to be farther away from the comet. So the point being that, oh, there we go. You actually see changes live in the universe in front of you. You just don't realize that you're seeing things so dynamic in the universe. Now, granted, it's kind of slow motion. I grant you that. It looks like it's a bit slow motion, but it is, right? But still, the comet is moving about 150 to 160,000 miles per hour right now. Yet, there it is. It's not zipping across the sky. But you got to remember, it's millions of miles away, several tens of millions of miles away right now. And so, something that far away, taking up this much space, I mean, this tail is millions of miles long. So it's taking time to actually see the result of its motion. But we see it. We can actually see it. So now notice that star right there with the nucleus right there. Okay. Now what I'm going to do is we're going to come out, okay, and go back into our 1 second low light mode. Okay. All right. Okay, there we are. All right, so now we don't really see that star. We're kind of just in this low light mode here. But the star it's in here. We know it's there. It's like right about there. Very faint. And so as we get to the point of taking another photograph, we're going to actually see how it actually fleshes out. You actually watch what happens, and you'll see how the nucleus is a little farther from that star the very next time we take the picture. So let's go back to our stellarium here. So the comet's actually quite much lower in the sky right now. So detail is getting harder and harder to see on the comet, actually. But it's such a broad detail that you can't really tell that it's harder to look at right now. Alright, so that's our comet. And our field of view is this right here. That's our field of view. Okay, and I actually have it shows this telescope as being right here. It's not exactly true. So the comet is right there, and the center is there. So it's actually not that far off. So what I can do is I will synchronize on this as it is, and you'll see our crosshairs line up on the comet. It's actually pretty close. Actually, that's more like what it is. So that's good. All right. Oh. Guess I have that going on too. All right. So now let's go back in. And that's our previous image. There's that little star. And when the next one comes in, it's going to overlay it. Now watch.
It's pretty distinct.
Yeah, look at that. So you can see that the comet nucleus is moving away from the star by a very little bit each time. Pretty cool. That's neat. Okay, and then down below here we have the anti-tail. Which is actually this tail winding around. and looking at like it's sticking out from the front of the comet. Because as I said, as the tail goes around the sun, it lags behind, and so we can see a perspective effect of the tail seemingly sticking out in front of the nucleus because we're looking at it from this perspective. So here's the nucleus, here's the tail, but it's really part of, you know, this whole tail here. It's part of this whole tail that we're not really seeing in this particular perspective. Okay. Okay, we'll save it again here. This is 4 shots, 5 shots. Okay. All right, well, it's getting pretty low. So what we'll do is we'll go to a new object for tonight. And the next time we stream, we'll take a look at the comet one more time. I want to say hi to RJP. How you doing, RJP? Nice to see you. Okay. Lucky Luke, nice to see you, man. Okay, so we'll get out of this. And
Messier 10.
that's right nearby.
Yes, it is.
It's like, might be just as low to the horizon.
RJP, anybody that's interested, when I got into light pollution back in the 90s, I drove from Colorado Springs straight east to the Kansas border, 150 miles away, and the sky glow over Denver, the Springs, and the rest of the Front Range was immediately noticeable 30 years ago. And I can guarantee you it hasn't gotten any better in the meantime. 150 light years away, and it was obvious in the western sky.
10 is even further south down here, Daryl.
Oh, okay. Well, how about M5 then?
Okay, well, we got M14 here, but M5 is better.
M5 is Serpens, right next to Ophiuchus. I forget if it's in the head or the tail.
Oh, we'll find it. Oh.
Oh, okay. Never mind.
Yeah, wrong, Ma.
Must be in the head of the serpent.
Guess so.
Ophiuchus is you can see the figure that the comet is in. He is called the serpent bearer, and he's associated with medicine and the caduceus, you know, the 2 snakes wrapped around a staff, stuff like that. He is holding a snake in his arms, and the head is to the west and the tail is to the east on either side of the guy holding the snakes.
Yep.
I bet Stellarium might even show that.
Maybe.
But carry on with what you're doing.
Okay, well, I'm going to shift us way up into Cygnus, show some folks a beautiful nebula that's very hot in the sky, so they can see how the telescope performs with a beautiful nebula. Okay. Now I will make sure that we're focused, because when the telescope flips up high like that, we tend to get a thing happen called mirror flop, and the mirror will flop. Actually, it looks pretty good. Now what I'll do is identify, oops, sorry. You can kind of see some red nebula in here. That's kind of where we're going. This might be the eye of the pelican right here. But let's go see. Let's solve for this. Yeah. 57 Cygni. Yeah. Okay. So So we got a lot of things. Here's the Pelican, yeah. Okay, so we have the Pelican Nebula right in front of us here. This is kind of cool. I will show you. Okay. Let's go in to Stellarium and center up and then zoom in. Okay, this is 57 Cygni, the star I'm talking about. And this is pretty much our frame. It's a little bit over a little bit more, but that's okay. So we're going to take this image of the Pelican. It's really pretty. And we'll do a 25-second shot.
Mark, excuse me a moment, please.
Sure thing. And we'll go into our low light mode. You guys are going to like this. There's our previous shot of the comet. That was a pretty comet. We'll check it out again on the next time we stream, which it's like we average every other day. Okay, so it's up there, saved. So here comes image 1 of the Pelican. And the Pelican is a gorgeous nebula. It's part of another complex called the North America Nebula. And it's just beautiful. And it has this beautiful area here that's much redder. So let's color correct first of all. Alright, and now we will do a little processing. And it's going to do that to us, yes. Alright. This complex is approximately 5,000 light years away, and is illuminated by this there's hot stars in the area. Some of them are actually inside this dark dust. Believe it or not, this is not avoiding the stars. This is dark dust sitting here in front of the nebula, and you're seeing the nebula behind this dark dust, so it's occluding what's behind it. Yeah. This area here is an area where the hydrogen gas is denser than the dark dust, though therefore we see a more red color. It kind of looks like a three-dimensional shading, but we have to be careful with that because it's not quite that. But we're seeing a lot of dark dust in here, a tremendous amount of dark dust. And this dark dust is something that is very much will change the color of the stuff behind it when it's actually there. Like right here, we have a layer of dust that's probably in front of this. This here, it's denser. The hydrogen cloud is denser, so we see a more red cloud. And the dust is overwhelmed by the density of the hydrogen in this region. It is also possible that there is slightly less dust at this location for whatever reason, but this area is just really just replete with dark planet building and star building material. All the hydrogen gas, which makes up stars mostly, hydrogen. The hydrogen is the #1 element in the universe by abundance. Second is helium. Third is oxygen, believe it or not. And fourth is carbon, what you are made of.
Folks, if you see the head of the Pelican there, the dark eye it has, look just to the left of the eye of the Pelican, and there's two bright stars there. Do you see a raccoon or an opossum looking over the Pelican's shoulder?
You talking about these two stars?
Yes, that one, the one to the right.
Yeah, okay.
Don't you see a possum head or a raccoon head there?
Oh yeah, like there's the nose.
Yeah.
Here's the head, the forehead, snout.
He's looking right over the Pelican's shoulder.
Eyeball.
Over his beak.
Pelican beak, yep. Yeah. Absolutely.
They should call that Mason's Possum Nebula. I'll be famous. I'll be rich.
Yes, because everybody who's found the nebula is rich.
Well, I'll be famous anyway.
Okay. Here, we'll darken that up so you can see some more details. Look at that, guys. Wow, that's pretty. Now, all this dark dust you're seeing here, all of it, was liberated in several ways into the interstellar medium, into the universe. First of all, it's within our galactic spiral arms. Okay, the dust seems to congregate there because that's where active star formation occurs, and that's where the biggest stars, the brightest and hottest stars will form, and they're the most short-lived, and when they explode, they release and send back to the universe the material which can then be made into dust particles that we see here. Stars make carbon in their cores, and so when it goes supernova, that carbon is released. Stars that are like the sun also can make carbon, and it can be released into the universe in the same way, but through the star death sequence. But with a star like our sun, it becomes a planetary nebula. It shrinks down to a white dwarf, kind of a quiet way to go, and it sort of sloughs off its outer layers. And those outer layers contain carbon and all the other elements that the stars were made with, and that the stars make in their cores. So some of that material does get out. So that's kind of cool, and that's what populates our periodic table, and that's what allows your body to exist. Every element in your body was made in the heart of a star, which is really crazy to think about.
Carl Sagan said that in Cosmos 40 years ago.
We are star stuff. We are star stuff.
That used to blow people's minds when I'd tell them that I do public presentations and star parties for the state parks here. Mm-hmm. And I'd tell them that the gold in their ring came out of back then they thought it was supernovas, and now I guess
Merging
the heavy comes out of merging neutron stars.
So if you think about it, right? I mean, neutron stars don't seem very numerous in the universe. Yet, it seems that merging neutron stars would be even less numerous. Yet all the gold that we know of comes from the merger between neutron stars. Now, that means a lot of them had to merge at some point to create enough gold that we have veins of it here on the Earth, trickling through our crust. And the way the Earth was formed is very miraculous because it was formed through a process called differentiation. It was a molten ball, and as a molten ball, heavier metals could settle toward the core, and radioactive metals could settle toward the core. In fact, the core of our planet is like a reactor of sorts, and it's got a radioactive central core that is actually keeping a lot of heat going. There's also the heat of formation, from early formation. But when you think about it, gold is a heavy metal too. So why isn't it all down in the core? Well, because of the nature of the turbulence of those outer layers, a lot of strings of material were thrown up into the outer reaches of the mantle and into the crust that had formed and that was forming on the Earth, and froze there. And those became the veins of gold that we find. So it's interesting how that works.
I used to work in mining. Trust me, I know. I worked in the largest underground mine in North America a long time ago.
You did, Leadville, right?
It was a molybdenum mine, which is used in alloying steel and making lubricants and stuff. The richest veins of molybdenum and other metals followed the fault lines in the rock. And they would occasionally, the miners, I mean, we were in the business of producing molybdenum, but miners being miners, they would, if they hit a vein of gold, well, sometimes they'd start following the vein of gold instead of the molybdenum. And uh, underground was laid out by engineers, and everything was shot with laser levels and very precise where the tunnels and the following the veins and production and stuff was supposed to go. And the boss would check the miners in the morning, and well, they were where they were supposed to be, and he'd come back at lunchtime, and they started drifting off to the side following the veins of gold.
Mhm.
And when they did that, they would remove all the hourly miner employees. Management would come in and build concrete forms, and they would wall it off, supposedly, so it couldn't be got at anymore. But rumor always had it that up in the mill above ground where they processed the ores to produce the molybdenum and stuff, that back in the back there was a table processing gold behind locked doors.
I bet it was. I bet it was. And it went into the pockets of the owners of the mine.
Something like that, yeah.
Yep.
There are a couple of famous gold mining areas just on the other side of the mountain from where we were. It was all through the place.
I wonder. I wonder just how much gold was extracted by miners that never was accounted for.
We'll probably never know.
Yeah.
But there's a thing called high grading in mining, and high grading is when miners find interesting specimens, shall we say.
Yeah.
They put them in their lunchbox and they carry them out,
Yeah.
unbeknownst to management. It's called high grading.
Well, I would probably have high graded a few things myself.
Yeah, well, it's a thing as old as time from the first miners.
Yeah. Did you ever high grade anything, Daryl?
Um, I was a mechanic, so I got to see the ores after they were already shot and brought closer to the trains. But I'd go over and pick through the piles sometimes, and I found some interesting crystals, pyrites mostly, and sometimes the pyrite was gold. Sometimes it had all sorts of neat colors shot through it in a chunk of rock, and I took those home and put them on the shelf just to show off. Still have them 40 plus years later.
Daryl's probably got like a $4 million nugget up there and he doesn't realize it.
Oh, not even.
Okay, 3 million.
There was a guy I carpooled with from Breckenridge to the mine for a while. He found a crystal of what's called rhodochrosite, which looks sort of like a milky ruby. And that thing, it was easily worth $1,000, the chunk he found.
Back then?
Yes,
So that's a lot more now.
no doubt.
Wow.
And it's no accident there were rock shops in Leadville selling stuff that miners had snuck out in their lunchboxes.
No accident. Well, here I am. I'm thinking that one of my favorite... I mean, I have a whole fossil collection here. And in my fossil collection, I also have some natural occurring objects, too. Like, I went digging for some dinosaur fossils, and I discovered a Jurassic rainstorm. It's a platter of shale that actually has droplets the size of your thumb in there. Giant drops from a Jurassic rainstorm that had occurred and then got quickly passed over by another type of mud and sealed it forever, and it became a fossil. Really pretty. I have insect amber, an insect, a bee in amber, forever encased in amber, and you could use it I have a microscope, and it's very nice. It's ice, and you look at it and you see every little detail on the insect's body. It's gorgeous. And it got trapped in the amber, and it's like, wow. You're looking at a creature that lived in this amber tens of thousands of years ago. You know, pretty cool. Maybe even longer. So it's pretty cool.
There was an amber room in Russia before the communist revolution, and they might have kept it then. I forgot. Either the Bolsheviks or the Nazis during World War II tore the room out and took every bit of the amber. The entire room was coated in amber crystals.
What a horrible thing to do.
Human nature.
Yeah, I hear people that, you know, they choose to destroy ancient works, you know, for what reason? Who knows?
Yes.
Stupidity.
Vandals.
Yeah. So look at this beautiful image of the Pelican Nebula here. Obviously that's not all of it. It goes down below the screen as well. But we'll save this. And then save exactly as seen. That's 24 shots at 25 seconds apiece. We'll come back to our low light mode.
There was a geologic feature along the path of the Lewis and Clark expedition somewhere on the upper Missouri River called Pompey's Pillar. Pompey was the son of Pocahontas, if I remember correctly, and some punk teens some years ago supposedly knocked down Pompey's Pillar.
Yeah.
Just a pure act of vandalism.
Well, stupid people do stupid things. And it's just not right. Alright, we're gonna come down here. I know Cosmic Ray wants us to image the Veil Nebula for sure, but I think we'll skip it.
Don't tease him like that.
Okay, let's try 6823. This is really cool.
I don't remember his name, but the face rings a bell. Old joke.
Yeah.
6823, remind me.
Tulip Nebula, I believe.
Okay, all right.
Let's go back and see if I was right about that. It's Sharpless 2-86. It may not, I'm not sure if it's a tulip actually. I seem to recall it might be.
The name the number sounds familiar.
Yeah. Okay. All right, let's image this. Let's go here and make sure it's this right here. Gonna annotate it and see what we got. NGAC 6823, there it is, right there. Okay, and we'll save the image with the annotation, so if anybody wants to see it, it'll be out on the server.
I think I see a dark area to the upper right and maybe one to the upper left too.
Here?
Yes.
Alright, let's find out. Okay, we're gonna do a 25-second shot here. And we'll go into our low light deep sky, our deep sky mode. You can follow the progress by looking over there on the right side of the screen. Okay, and we'll clear the previous image of the Pelican. And now we'll look at another nebula, a stellar nursery area. up in Cygnus the Swan, which is where we are right now. We're in Vulpecula right now, I believe, which is right next to Old School. Thanks for coming along. Good to see you, brother. All right.
Yeah, there's a little bit of dark stuff there.
Yeah.
Kind of a dark meandering
Right here.
stream on the right there, from above to down to the lower right, and there's a little dark area there to the upper left also.
Yeah, there is. There's a lot of nebula in this region.
Yeah.
Notice
We're
how,
looking-
as the second image came in, guys, it actually got so much better. That's the stack doing its work.
there's a really sharp dark line just to the upper left of that star cluster.
Right here.
Yeah.
Yep. This is not the tulip. The tulip's another one.
Cool anyway.
It is. Yeah, this is cool.
That's actually interesting band of dark nebulosity there to the runs from about 12:30 down past 3-4 o'clock
This
down
guy?
to the over on the right.
Oh, this guy?
Yeah.
Oh, okay, yeah. It
Goes
also
all the way
splits
down
off.
to the bottom of the screen.
It splits off with filaments. And there's some down here, too. Reaching up in. As winter approaches, guys, I'll be able to show you some very, very cool items in the winter sky as well that are really cool. By then, we should have our Benson scope up and running, and we'll be able to do some spectral work, spectroscopy work that you guys get to see, narrowband imaging that you'll get to see, and imaging like this as well. And the sky in Benson is actually incrementally darker than this sky we have, which is kind of fascinating. I didn't realize that until we checked it out, you know. Oh, and I'll be there next week, by the way. That's the other thing.
Oh, heck, you're down southeast of Tucson there.
Yeah, I am.
You're like 10 miles from the Mexican border, aren't you?
Not that close, no. But we are, you know, it's going to be, it's a dark sky area for sure.
Yeah.
Yeah. And we're at a higher elevation than we are here. That elevation, I believe, and I think it's another 1,200 feet higher than this. Every little bit helps. And we're
Sure.
at, this one we're at around 1,100. I think we're at 2,400 up there in Benson. I have to go remind myself. Yeah, this is pretty.
I was at about 10.5 or 10.6 when I lived in Leadville.
Oh, yeah. Yeah, you were way up there.
Had dark skies.
Yeah. I wonder how dark it is today.
Probably not as much as it used to be. I know over in Summit County, where Breckenridge and Frisco are, my sister's place that was outside town had nice dark skies, and then the lights of Breckenridge, it has its own little light dome going on now. Kind of half wiped out the sky up there now, which is a shame. When I took my best pictures of Hale Bopp in '97, I was up near the top of Wilkerson Pass here, and looking in the direction of the comet. I didn't see it in by eye, but when I took pictures along the horizon for the comet, little light domes showed up over Breckenridge, Keystone, the ski area. God, they must have been 50 miles away, and they weren't that big. They've gotten huge nowadays. population of Colorado has basically tripled in the time I've been here.
There's an interesting star here that seems to be illuminating a nebula around it.
That looks familiar.
It looks like dark dust here that's being illuminated by the star and also ionizing some hydrogen, giving it a reddish glow. Very cool. That's very cool. I dare say we're probably the only ones on Earth looking at that little tiny piece right now. No one else is looking at that. And you folks are along for the ride. Django, what's up, brother? Nice to see you. Ronald, Earth Radio, nice to see you. And Martin is with us, Podcast UFO. Martin Willis, if you haven't seen his show, you've got to be part of that show, Podcast UFO. If you look it up on YouTube, you'll find it. You'll find how to get to it. Martin Willis, good friend. I was on his show earlier announcing this stream, so if some of you are in here from his show, let me know. Izabela says, what time? Martin, put in the times of your show. I believe it's, is it Tuesday 7 to 9? Let me know, Martin. Put that in the chat. Okay. We're at 16 images. Notice that the detail's getting much better. Let's go back to our histogram here and let's try and pull out a little more detail. Okay, there you go. Izabela put it up. Thank you, Izabela. Podcast UFO information provided by Izabela.
Karen, not me. Farthest south I ever saw was near the Mexican border down in far southern southwest New Mexico back in 94, 95. I've talked about seeing Omega Centauri from down there. It's the only time I've ever seen it. And it was gorgeous. Omega Centauri is the biggest globular cluster in Earth's night sky. It's about the size of the moon in the sky. It has like 4 million stars in it. It's huge.
Hopefully we'll be able to see it with our Benson telescope.
Mm-hmm.
They were putting in first.
You know, Karen asked Mark and Dee sending any lovely night skies from South America or Australia. I wish.
Well, I used to be. Well, I'm actually. I'm in a project with the Las Cumbres Observatory Association now, looking for exoplanets around Barnard Star and around the Garnet Star, Mu Cephei, Cephus. They have telescopes in the southern hemisphere, so I guess we could get some images down there. I think they have like a 1 meter system, but they got like 25 different telescopes around the world. Neat stuff. Very, very neat. Okay, let's end at 22 here. Okay. That's beautiful. The wonders of the night sky. Okay, and that'll all be up there. Wow. Alright,
Karen.
guys. I think I'm tired and I think I need to go to bed. But go ahead. You were saying to Karen Belmont?
Yeah, she's talking about night critters in the Arizona desert. I can tell a story, but I'll save that for another time.
Okay. Well, obviously, um, we've had our own interesting encounters with night critters. I remember our Marianne and Tara went out to do some maintenance. Tara brought her husband Dale, and they encountered a creature underneath the computer out in the observatory. The creature was the size of my hand, and it was a tarantula. It was a large desert tarantula. And if anyone knows about tarantulas, they're very docile. They don't want to bite. They don't want to spend the energy to bite you. You know, if you're not hurting them, they'll just be happy to crawl all over you and not bother you. Just don't squeeze them and poke them and prod them and expect them to just take it. You know, so to get him out, Dale just put his hand down there, and it crawled up on his hand and started crawling up his arm, and he walked out with it, and he kind of helped it off into the dirt outside, and that was cool. Really neat. Got some nice photographs of that.
All right, if you're going to tell stories,
Go
I get
for it.
I get to tell mine.
Yeah, you do. Go.
The night I saw Omega Centauri, I was out in the middle of nowhere, east of Deming, on the other side of the mountain, and west of Las Cruces, not far from the Mexican border. I set up my telescope that night after sunset. It was getting dark, and I got her set up, and I was waiting for the dark to, come completely, and I looked off to the south, the desert floor. The desert floor was actually kind of a light color, and way off near the horizon, I thought I saw this black thing, and I noted it, but I kept, just looking around everywhere, waiting for it to get dark. And I happened to look south again a little bit later, and that black blob was still there, and it was getting bigger and bigger and bigger over time. And I started worrying some. I guess the little scared kid of the dark in me, I started imagining things like demons coming out of the dark, or chupacabras, as somebody said, and here comes the devil from Mexico right for me. And I kept watching. It got darker and darker, and I could still see that black blob, and it took a shape, and it was getting bigger and bigger, and it walked right up to my telescope. And what it was a huge black bull being followed by a few mangy-looking cows. That bull came right up to the scope. I had gone over to the far side of my van at the time to put some distance between me and the bull. That bull, he had drool hanging off his nose and everything. And he came up and inspected the telescope, and he looked at me, and then he turned around and led his whole herd of cows off back into the darkness. That scared the willies out of me that night.
I believe it. Okay, I got one more. By the way, this is the Dumbbell Nebula. This is a nebula that is characteristic of a nebula that our sun might produce when it finally runs out of hydrogen and decides to swell into a red giant, puff off its outer layers, and then shrink down to a white dwarf. These outer layers are composed of oxygen in the green and hydrogen in the red.
A little bit of neon, too.
Yeah, the neon's a little bit of red, yeah. And there's more than that in here. There's a lot more. And the color is now corrected. Previously, it was showing as blue, but this is actually the correct color for the oxygen. And so I'm going to drop this down inside to showcase this guy in here. That right there that you're seeing, that and I'll put a red square around it. That right there is a white dwarf, and it's powering this ionization of this gas here. And the white dwarf is the end state of a star, kind of like the sun, a little bit more massive and a little less massive. And so the white dwarf is about the size of the Earth, and the star used to be, like our star is about 850,000 miles across, 860,000. But you could also have stars that are just over 1 million miles across, and they're still going to go down to the size of the Earth as a white dwarf when they're done. So when that happens, for instance, you can imagine this nebula, which spans approximately 2.5 to 3 light years in diameter, will of course eat up the planets, and it'll be hot, so most likely the planets will be, at least the inner planets like Mercury, Venus, and possibly the Earth, will be swallowed up by the red giant stage of the star alone. But then the nebula will be this hot but sparse gas. I mean, it's not very, very dense, and this gas will actually be extremely hot, so it will affect the outer layers of, say, Jupiter's atmosphere and Saturn, Uranus, Neptune. Pluto's surface might melt. For a period of time, Pluto might have a thicker atmosphere briefly, but then it'll all go away as that radiation starts to wane in temperature. So that's the end state of a star like our sun, and that's what we're seeing here. This is the Dumbbell Nebula. It's famous. It's one of the first things that people see in their telescopes. It's one of the first things I saw. And,
Me too.
Yeah, and you too, right? Yeah. And when I looked at it for the first time, it didn't look like this, like I have it here, okay? It was actually more like a very faint version of that. Let me actually bring this back down just to kind of give you an idea. Okay, that's way too bright. It didn't look anything like that. It looked like just an hourglass. So if
Ronald asked the question,
yeah,
will Earth be gone in the ending of our sun? I said, will the Earth still be there after? It'll probably be inside the sun when it turns into a red giant.
That's one of those arguable things nowadays. They're thinking maybe the red giant stage will go out just past Venus's orbit and not reach the Earth. So, but the Earth will be incinerated. The oceans will boil away. Yes, but it's true that the Earth could be swallowed up by the red giant, and of course, even though the red giant is lower in temperature at that outer region, it's still a star and it's hot plasma. So you will, of course, boil away the Earth too. This is about what you see in a somewhat small telescope for the Dumbbell Nebula right here. And as you get larger and larger telescopes, you see more and more detail. Okay, so in my telescope I had when I first looked at it, I saw it like this. Okay, I could see those little outer wings. All right, and then as the telescopes changed, I got more able. I was able to see detail out here as well, as you can see it now with me. So now let's take.
I saw pretty much that minus the color in my first 6-inch telescope.
Well,
I mean, I said before it looked like what?
You didn't see this outer area.
Oh, what I saw was pretty round, and I've said before it looked almost like a ghost planet Earth. If you squint when you look at that and take the color away, you can almost imagine North and South America in that picture like that. And it looked like a planet, and that's why they call them planetary nebulas.
Well, I was looking at it. My very first telescope was a 2.4-inch refractor, very small scope, but it was my telescope. Yeah,
Sure.
and I looked at all kinds of great stuff with that. And then my second telescope was an 8-inch Schmidt-Cassegrain telescope, same kind as the one in our observatory here. And then I got another one that was a 10-inch, and now we have an 11-inch Celestron. The 10 inches here in the building, and then we have the 11-inch Celestron that's going into the Benson Observatory first. All right, now let's see. So the dumbbell is gorgeous. This is a good balance because we can still see the white dwarf inside. The white dwarf surface temperature is in the range of 35,000 Kelvin, which is very hot. And if you think of the Kelvin temperature scale, there's a conversion you have to go through to get it to Fahrenheit, but it's actually only 273 off over Celsius. Okay, so if you go to minus 273 degrees Celsius, that's absolute zero on the Kelvin scale, which is minus 459, I believe, Fahrenheit. Absolute zero. So you kind of get an idea how the scales work. And why did we do Kelvin scale? Well, we want to have a temperature scale that wasn't negative. We want to have a 0 point, and that is very helpful when you've got equations that you're working with. Temperatures are in Kelvin, so you can always be sure that you're not going to get a negative number in your result, and then you have to account for the negative number.
Yeah, the rate of change is the same as Celsius.
Yeah. Hey, Fantasy. Yes, we used Kelvin in chemistry as well. Whether organic or inorganic chemistry, all your temperatures are in Kelvin. That's right. Fantasy had mentioned that about chemistry. Yeah, see, so 22 images. I will change this to dumbbell. Notice the color is different. Daryl? Remember our dumbbell nebula last time was very blue?
What did you do?
I changed the color response to the proper color response to match the oxygen to what it should be.
What, on the sliders down at the bottom right?
No. That's doing its own thing now, but it's matching it to the color, the base color map that's being used now. The proper color map for oxygen to the frequency. So these are the right colors now. The blue is pretty, but this is reality.
I like the blue.
Okay, tell you what. For you, let's give you some blue. I can fake it with this.
I mean, this looks like what you had on your last camera.
Yeah, except it's got more
It was
detail.
it was screaming green and orange instead of red and blue.
Yeah, but
It's quite common other astrophotography that it's a blue color.
yeah,
That looks like your old camera.
except it's better. Because this is definitely it's the right color response now.
Karen, the red is hydrogen, the green is oxygen. Izabela has a good question. Do the areas with different elements, green and red, have different temperatures?
I think there's an ionization temperature for different atoms, yes. It's not just one magic number for all, but the oxygen is actually doubly ionized and the hydrogen singly ionized because it only has one electron. So if the temperature is hotter, then it can ionize as many atoms as can be ionized at that temperature. So it's not that they're discrete separate temperatures. It's a temperature scale that's a discrete value, and any element that's in there that can be ionized will be ionized within that diameter. You see what I mean? So it's not like there's different thresholds for ionizing oxygen versus hydrogen, yes, but the ionization process will affect all the atoms that can be ionized at that certain temperature and within that radius of ionization that we get, which is apparently out to here.
I would imagine it's closer, it's hotter the closer to the white dwarf.
It probably is. Yeah, I mean, the temperature, first of all, there's no temperature in space. It's actually radiation. So the radiation falls off as the square of the distance. Okay? So it is 1 over r squared law as it leaves the star. Okay? When it gets twice as far away, it's 4 times less intense. 4 times further away, it's 16 times less intense. And so that's how we can see when something's getting ionized. If we look at its intensity, we can figure out, well, okay, this stuff is this far away from the star, therefore it's 4 times further away than this, so therefore it's going to be 16 times less temperature out here in this this gas will not be energized to that level. However, it's still hot enough to ionize. So in other words, the energy level of this stellar radiation coming off this white dwarf is still going to ionize oxygen all the way out to here. So it's interesting how it works, but it's not something that is indicative of separate temperatures occurring at different parts in the nebula. The white dwarf is a certain temperature that's not really changing, and it radiates out. Temperature falls off. The radiation that's radiating it out is falling off at the square of the distance. So the farther out it gets, the less intense it gets. That's why it doesn't ionize oxygen that's out here from something else. RJP says, could some of the oxygen in this nebula potentially be from potential planets in the star system when it was still main sequence? I don't know about that. I mean, Daryl just answered it too. It seems that the star is going to have a lot of oxygen in it. Don't forget, oxygen is the 3rd most abundant element in the universe. So that 3rd most abundant element as oxygen is going to be very present in most stars. In fact, stars like this size star that maybe this was could make oxygen in its core, probably. Maybe not. But the envelope around the star, okay, that envelope will have been made with some oxygen in it as well. So there'll be oxygen nuclei in the star's envelope.
Sam says he sees the image brightening and dimming, and I'm seeing the same thing.
Yeah, I see that too.
Pulses. Is that just a artifact of the camera, I assume, or the processor?
Yeah, I'm wondering. I see that happening as well.
Just now.
Yeah. I'm wondering what that is. Let's see if it happens when we pump this way up.
Yep. Yes, it does.
Okay, so I didn't see that before.
Huh.
Interesting. It might be the threshold. It might be on the verge of a threshold. Let me see if I bring this in here. If that changes anything. Nope, still doing it. What if I do this? Let it go to where it wants to go.
Still doing it.
Look at that. That's strange. I'm not sure why it's doing that. I will have to find out. I will save it like this though. Okay. And then we will move this way down so I can show the white dwarf and take that photograph.
Karen, if you mean Betelgeuse going supernova or its brightness fluctuations, I haven't heard anything recently. There was some talk fairly recently that they think Betelgeuse actually has another star inside it, which may be stirring things up. It's a binary star, but Betelgeuse was blown so big in a red supergiant phase that the other star is actually inside the envelope of Betelgeuse now.
I heard that. I'm wondering what that's all about, too. Alright, folks, well, we are going to save this last image and exactly as seen, and then we're going to call it for tonight. I hope you had a good time looking at the comet and then the few other objects we checked out. So I hope you will come back next time. If you are just joining us for the first time, please subscribe, click the bell, and then drop it down and click all notifications. Make sure you get in the loop. Go to skytourlive.org, and also make sure that you stick with us because we do equipment giveaways as well, courtesy of Tiffany and Mike, who are in our chat. We're their exclusive giveaway partner, and we give away telescopes and binoculars, and eventually we'll be giving away night vision. Join our Patreon. If you join our Patreon, you can end up getting some beautiful swag, and you get final finished processed images of what we do at different levels. You'll see those spelled out in the different tiers. But I hope you guys will come along, visit our Etsy store if you want to get something cool to remember your time here by. And I will see you all next time. It's about time because my voice is getting shot. So you guys have a good night, and we'll see you later.
Good night, everybody.
Good night, everybody.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. distant dream. Live it real, like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky Tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky Tour is bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky